Can I get Braden at my desk ACP? Alright, I'll wait for him. Thank you. Hey, Braden! Hey, how's it going? Can you make a quick summary of Multiverses for my meeting tomorrow? I know, I'm sorry I'm telling you this now, but it's very urgent. Also, hold on. Derek is on another horn. Ahoy hoy! Yes. How are you, Derek? Splendid. And the family? That's great to hear. What? Oh, okay. Yes. I'll tell him. Thank you. Goodbye, Derek, and have a wonderful day. So yeah, news came in. He needs you to make the summary in a video format because his son has a project on it. And it's due tomorrow.
I thought it was for your meeting.
Yes, I'm meeting Derek to give him your video. After that, we're up for Olive Garden. Yes! Been waiting to go there.
What?
Shh. Do this, and I'll give you a raise. Deal?
Okay, fine. Deal.
Also, could you get that to me by this evening? Thanks, man. You're a real trooper.
Hey, I got some bad news. I won't be able to come tonight. No, I have work. Boss, same old. No, I'm not getting paid overtime. Hello? Let me ask you a question. Does the multiverse exist? Well, the answer is yes, but also kind of no. You see, the multiverses you're probably familiar with is the ones depicted in TV shows and movies, such as that one Spider-Man movie where there was a bunch of Spider-Men. But in our world, that's not really how they work. So, how do they work? Well, to start answering that, let's talk about quantum mechanics. So, you might have heard about Schrodinger's cat, and what happened to him. And the truth is, they didn't know until they checked up on him. Anyways, Schrodinger's cat is a thought experiment where inside a box there is a cat. And also inside the box there is a mechanism that could release poisonous gas if it detects radioactivity. And there also happens to be a radioactive isotope inside the box. What do you know? But luckily for the cat, that radioactive isotope has two options. It could A, get detected by the poison mechanism and kill the cat, or B, it could decay, ensuring that the poison mechanism never sets off and the cat survives. Now I know you're wondering, Braden, what does this have to do with multiverses? Well, think about it. If we consider superposition, the idea that something can be in two states simultaneously, we can imagine a scenario where that radioactive isotope is both alive and well and also decayed. Although, eventually, that isotope has to make a decision. And so depending on the state of that isotope, there could be two very different outcomes. In the realm of quantum mechanics, quantum meaning very small, things get a little weird. It's not like classical physics where I could have a tomato and with the right trajectory, the right force, and the right time, I could throw a tomato so perfectly that it hits my boss and knocks him over. Not that I would ever do that. However, rather, in quantum mechanics, probability determines many outcomes. For example, an electron around an atom is most likely somewhere, let's say, around here-ish, but there is also probability that it might be right kind of there. And, well, that is all dependent on the wave function, and it collapsing when and only when you observe or measure it. And unfortunately, there isn't really a certainty principle. However, there is an uncertainty principle. And it's also known as, get this, Heisenberg's uncertainty principle. Anyway, it's the idea that the more you know about the location of an electron, the less you know about the momentum. And so if you really wanted a precise location of an electron at a given point, you would actually get the probability of its momentum. And if you wanted to find, let's say, the exact momentum, you actually wouldn't know the location. Instead, you get the probability of the location of an electron. And this is a basic property of quantum systems. Not because of our tools and how they really can't measure perfectly. It really is a part of quantum systems. And, shoot, I forgot about entanglement. Well, quantum entanglement has to do with the linkage between the states of two or more quantum systems. Basically, if the radioactive isotope decays, it is entangled to the Poisson mechanism. And that entanglement is then extended to the cat. In our case, of course, and whether or not it's actually alive or dead. Objects that are not part of the quantum system, such as an observer, are not entangled. Okay? The observer's observation is what causes this wave function to collapse and determines the state of superposition, thus the outcome. If you're confused about entanglement, then I would check out the views in the description for some more insight. Oh yeah, so anyways, if you want to learn more about the other quantum physics concepts, Veritasium has made a video that goes much more also in depth in the description.
So there's this guy named Sean Carroll, very educated dude, and he knows a lot about multiverses. Or at least the theories behind them. Okay, yeah, sadly, multiverses really are just a theory, but that doesn't mean they don't exist in some capacity. Sean Carroll has talked about the two main theories behind multiverses, one of which has to do with cosmology. The cosmology theory, or perhaps the inflationary theory of cosmology, says that our universe is one of many different bubble universes. And those other bubble universes might have different properties, such as gravity, which might be different. Other laws of physics might be different. And this is plausible because we don't actually know what's beyond the observable universe. And we can't actually prove if our universe is infinite or not, or if there is something else beyond our universe. Interesting theory nonetheless. But, big but, and I cannot lie, there is another theory. It's called the many worlds interpretation. And I know, it sounds cool, and better yet, it has to do with quantum mechanics. So, you remember Schrodinger's cat like a minute or so ago, right? Well, if quantum mechanics has to do with the probability of a certain outcome happening, then in a sense, the outcome represents two different universes splitting once, like in our example, that isotope or quantum system was measured or observed. So really, the outcomes represent two parallel universes. Now, I know we're only talking about one scenario, but did I mention that, like, everything is, in a sense, a quantum system? I mean, I was talking about a single radioactive isotope, but our bodies alone may radiate thousands of nuclei every second. And what about the other billions of people on Earth? Or the rest of the atoms on Earth? Or the rest of the atoms in the entire universe? With that being said, I think it's time to talk about multiverses.
So, then I guess there must be a lot of multiverses.
Yeah, I mean, we can't prove that another universe exists or anything, but in that sense, yeah, there's a lot of multiverses out there. Probably, maybe. Don't take my word for it.
Now, the idea that we can't prove multiverses may sound kind of lame, and in a sense it is. Plus, Hollywood's interpretation of multiverses sound way cooler than what physicists have thus far come up with. But then again, there might still be a lot of different versions of yourself, or rather, many versions like you. You see, Sean Carroll makes a really great analogy to this. Twins! When twins are born, they look the same. But over time, as they experience different things and do different stuff, or rather the universe manipulates them to do different things, it ends up changing that person. And so there really might be a version of myself where I'm my own boss.
I'm the president!
Or I'm a millionaire and also a stand-up comedian.
But I'm not a stand-up comedian.
We know. And so when it comes to understanding the multiverse, it's better to think of the other versions of ourselves as separate beings, or twins.
Or clones if they existed.
When it comes to parallel universes under the many worlds theory, there are certain cases where universes are not physically possible, such as when those universes break the fundamental laws of physics. An example of this is the probability of an electron suddenly turning into a proton, which is 0. It can't happen, and those branches of the multiverse are not physically possible. So yeah, multiverses, they're just kind of lame. You can't do anything with them, and they just end up with me daydreaming about what could have been. Right? Well, yeah, sort of, but look, this is the bit where I kind of contradict myself, so let's talk about time travel. Okay. Hand me that eraser. Thank you. Dry it off. This ain't no dry erase board, boys. Hey, next lesson's time travel. So is it possible? Well, probably not, since our math considers time to be continuous, like not stopping. And so yeah, and it's also one direction, so you can't go backwards, okay? And I also don't think so, because that would literally require like a lot of energy. Probably an infinite amount to travel faster than the speed of light. But, big but, if your goal was to, say, just relive the past, you may not need time travel. In fact, all you would have to do is move some atom and just move it back. I mean, I can grab it, move it back right there, just like that. And if we do this for every every basically particle, photon, I guess, whatever in the whole universe, well, in a sense, we could literally just make the past happen. And it still follows our continuous time stuff. The only issue is, entropy, world moving towards disorder and whatnot, kind of like a law of thermodynamics. Well, if I move this here and I go move something else, I mean, this guy might go back there. So, I mean, it would really, I don't know, it would take a lot of energy. It's like spring cleaning, but way worse. So, yeah, it's possible, but very unlikely, which is another bummer. And even if we could time travel, it would result in paradoxes like the grandfather paradox. And the grandfather paradox basically says, if I go back in time, and for some random reason, I decide to kill my grandfather, or I guess anyone else I don't like, and this is me doing it, I'm angry, okay, and I do that, well then that would have meant that I would have never been a little baby boy, and therefore I could not have been able to be born to kill said grandfather. This also works for your grandmother, for information. So that brings up another issue with time travel and things that could happen that are possible. Probably not because of stuff like that. But that's not to say it's impossible. We don't really know yet because, physics. But let me get my tinfoil hat out, since what I will say is not really backed up by science. This is kind of the fun part of class today, y'all. And I actually don't have a hat or a little poof poof, whatever you call it. Let me get this. So, okay. This is my crazy conspiracy hat, for the record. So, what if our world is a simulation? I mean, it could be. We can't prove that the universe is infinite. So, how can we prove that the universe is a simulation? So, simulation. What if we can create our own universe? Like, what if we took a point in time and decided to inject ourselves into that time via a giant simulation of the entire universe? Is it possible? I think so, just really hard. Like, really, really, really hard, because that would require a super powerful supercomputer, but still somewhat possible. Say, have you ever heard of the term metaverse? Well, it's kind of like that simulation thing, except instead, we could make our realities into something like a video game. I mean, why do people even play video games? To escape from reality and enter a virtual reality? Well, yeah, sure, but metaverses are not just limited to video games. It could be anything, even a 1-to-1 scale of Earth 50 million years ago. There's also another way to create a universe, similar to a metaverse, but not quite. Hear me out. What if you wrote, say, a movie or a film or a book, and you called it a fictional or cinematic universe? In a sense, you're still creating a universe, just one you can't physically touch. But then again, it's a universe that, first of all, doesn't take an infinite amount of energy to create, or a supercomputer, and you can still bend that reality to your will. You can change physics however you want, or see fit. And you can even make your own story within it. And that story could then be used in the real world to teach others. So, I thought I was going to say something. Anyways, that's all I have for Multiverses today. I don't know, bud. Hopefully your project does well. I hope you do good. See, man, make it in that project, bud.
Dude, what is this? This isn't how multiverses work.
Yeah, sure it is. Look, I even have a few credible sources right here.
Where's Marvel?
Well, that's a cinematic universe. This is the real deal. The many worlds one.
No.
Much more
Derek
realistic.
will not be happy with this. I'm sorry, this won't do. You know I'll have to let you go for this.
Really? Oh, come on, Can. You know I have nowhere else to go. I still have student loans and a freaking mortgage to pay off. I don't even have my car note fully. Oh no.
You should have seen the look on your face. Of course you're not fired, man. You cannot be fired. We're currently being filmed by a human being while you're pretty much a figment of his imagination.
So, I'm not fired? Really?
No, I was just really bored. But hey, look. On the bright side, now you're a more knowledgeable yet civilized person thing, kinda.
Well, what about that raise then? We shook on it.
I can. I don't even have hands. How could I have shook on it?
But
I'm a can. I don't even have hands. How could I have shook on it? I mean, it's not like the writer over there wanted to include some snippet where this universe is one where Lag Soda never opened his lid and decided to live a normal life. Eventually working a 9-to-5 in some shabby, unspecified office space that is secretly his bedroom due to a low budget. But hey, that's just a theory. A multiverse theory. Thanks for watching. Man, I always want to do
cut!